So the whole theme of energy coming in from the sun and then going back out to space is one of balance that we've looked at a little bit already. But kind of an amazing fact for you, and then we'll give you a little discussion of the history of this as well, is that long wave radiation absorbed by greenhouse gases, the red print I'm reading, keeps the Earth warm. Without greenhouse gases, Earth would be much cooler, about 59 degrees Fahrenheit cooler, in fact. That is a huge number if you think about it. Can you imagine if, in general, it was almost 60 degrees cooler everywhere on the planet, or at least on average, 60 degrees cooler? It's just hard to imagine. So greenhouse gases aren't a bad thing. It's just that we're in a situation where we're changing the amount of them, and it's changing things for us fairly quickly. There is a very strong association between carbon dioxide and temperature. And the graph at the bottom shows us that. The basic statement is that periods of low atmospheric greenhouse gas concentrations tend to be cooler, and times of high greenhouse gas concentrations were warmer. So that is, and by the way, if you're in the PowerPoint slide earlier on that, you get a little narrative about that graph, so a little context there. But how do we know such a thing? The amazing thing is, if you go to Antarctica or Greenland, they have these really, really, really thick glaciers, thousands in some cases of feet thick. And every year there's a warmer kind of summer and colder winter pattern. And there's a little melt in the summer. And then in the winter, the things don't melt at all, of course. And so each year there's a layer, and it's mainly influenced by the temperature of the summer and the sunshine itself, which melts some of the surface. So every year there's a new layer. And so if you dig down in ice sheets, the farther you dig, the older they are. Of course, the stuff up there on the surface, if it's still an actively forming sheet, growing sheet, which we don't have too many of those anymore, but if it were actually growing, it would put on a new layer each year. So what that gives us over time then is a glimpse of the past. And what it tells us is in the air bubbles. When the water freezes, there's always some air bubbles, and those air bubbles give us a snapshot of what was in the air when those bubbles were formed. We're able to measure carbon dioxide concentrations. We're able to get a proxy or an estimate of temperature as well based on what we call oxygen isotope analysis. And we will later spend some time with a glaciologist who can bring us a little more about the science of that. So literally, going back to those ice cores, some of those have enough layers in them to go back into the hundreds of thousands of years range. So that many layers is really quite a remarkable thing.